All right. Now I'll be teaching you guys on the topic of the functions. So I'll be focusing more on the linear functions so that you can get the basic of it so that you can understand. All right. So when you want to write the formula of the linear functions, the formula of the linear functions is always y it is equals to mx plus c. So what does m represent in that formula? So m it is always represent the gradient of these functions. So guys, so always when the m is positive, it's always as you can see the line that I just draw here, it's also starting from the down going upward like that. So when m is a negative, which means when m is a negative gradient, it's always start from up going down. So the C in the equation, it represents the graph where the linear intercepts the y-axis. So every time when you guys are asked to draw a linear function graph, you must always find the x-intercept and the y-intercept. So for you to get the x-intercept, you must always say for x-intercept, you must make y it is equals to 0 so that you can get the x-intercept of the graph. And then when asked to get the y-intercept, make x to be equals to 0. Alright. But the question is, how can you find the gradient of the graph? So for you to find the gradient of the graph, it must always be equals to m equals to the coordinate of y2 minus y1, x2 minus x1. So when you're getting the gradient like this, don't make a mistake of saying starting with y2 minus y1, and then on the x part you make a mistake of starting with x1 minus x2. That will make you to get the a wrong gradient. So please always when you're getting the gradient, make sure that your y and your x2 they correspond. In this case, like y2 it minuses the y1, and then x2 it minuses the x1. So you can see the order in that, ne? All right. So what happens when two lines are parallel? Just think about it, guys. When two lines are parallel, just think about I'll just use an example where you have a line that is like this and the other one is like that. So you can see that these lines, they have the same incline. So the incline is the same, it's just that they're starting on different points. You understand? So this incline is basically the same, but the points that they're starting at are not the same, which means that the gradient is the same, like this, which means the m1 of those two lines AB and CD, they'll have the same gradients because of the lines are parallel. So for you to determine the equation, which means if you had the gradient of m1 maybe it's equals to 2, which means you'll use the same gradient into CD, but you'll use for you to find the formula, you'll use the coordinates for CD, but the gradient that you'll use, it will be the same for m1. Okay. But if the lines are perpendicular to each other like that, which means that when you multiply the gradient of m2 times the gradient of m1, they must give you equals to -1. So let me just say you are given the gradient of m1, and then they say determine the equation of CD. You can't use the gradient of m1 and CD as the same gradient. It means that for you to get the gradient of CD, you must first multiply m1 times m2, it is equals to -1. Already I've given you the gradient of m1, so which means you're going to say the gradient of m1 times the gradient of m2, it is equals to 1. And then now you're gonna say 2 of m1 that you already had times m2, it is equals to -1. And then now you can find the value of m2 by saying 2 times m2, because I'll give you m2 equals to -1. Then you're looking for m2, then you're going to divide both sides by 2. Then your m2 is going to be -1/2. So note that the gradient is not the same like when the lines are parallel. So if you're not given the coordinates or the gradient, but only given the angle, how do you find the gradient? So in this case, when you are given the angle, for you to get the gradient of MB is equals to M equals to tangent of theta. Theta, it represents the angle. So whatever you get there, you'll get the gradient. But note that when you're getting the gradient of that line, if you were not given the angle here, maybe you were given the angle this side, it means that the only way to get a gradient, you always work from this side. So it means that for you to get the gradient of that inclination, it means for you that if you are given let me just say this gradient, it was, let me just say it's beta. So for you to get the gradient, you can't use beta. The only way you can get the gradient, you must use this theta here that you don't have. So for you, you're going to say b plus x is equals to 180. Let me just say you are given beta, which is equals to let me just say it is 110 degrees. So for you, you can't use 110 degrees to get the gradient, which means you're going to say 110 plus x equals to 180 degrees. Then you're going to say x is equals to 180 minus 110 degrees. X is going to be 70 degrees. So for you to get the gradient, you must use the angle of the side from the inclination, which is 70 degrees. And then you can get the gradient as m, it is equals to tangent of theta. Then tangent of 70 degrees. Then the value that we get here is the one that you get for the gradient. Alright, so the gradient is always starting from the x-axis going the other way around. Sorry, from the x-axis going the other way around. So it must hit the line, but it starts from here going the other way around, not the other way around. So if you're given the one for the other way around, like beta, you must know that b plus x equals 180 degrees because of the angles on a straight line. Get the value of x, and that value you'll use it to get the gradient that you want. Okay, so number 5, when asked to determine the domain in linear graph, just know that every time when they ask you to determine the domain, if they say what is the domain of this graph or what is the domain whatever, every time when asked this question in linear function, just know that the domain is always x element of real numbers. And when asked for a range of the linear graph, just know that it's always y element of real numbers.